spanning the globe to bring you the constant variety of jank, the thrill of victory, and the agony of defeat. The human drama of electronics repair. This is the Big Bad Bench Wide World of Jank.
Thank you to all my patrons. Hello everyone, welcome back to the Big Bad Bench. My name is John, aka Big Bad Biologist. And today, I think we're going to have some jank today. And it's not my fault. Well, maybe it is. Maybe I went back in time and worked on something. Because I have a feeling this is not going to be good on the inside. So have a look at all this stuff. And actually, here, look at this. This is awful. This is the CMOS, the real-time clock CMOS board for the Laser 128 that we're eventually going to work on. We're going to work on the MSX first, then we'll get back to the Laser 128. Look at this thing. And then actually, look over here at this picture. This is what that's supposed to look like. So in the video description, there's a link to this thread on Apple Fritter. And that's what this board is supposed to look like. And this is what this board looks like. I also posted a picture of this on social media. If you want to stare at this a little bit longer, this is after the ultrasonic bath. So this is about as good as this is going to get with just cleaning. So yeah, take a look at all that stuff. And let me say hi to folks in the chat. Oh my God, so many people already here. Thank you all for joining me. So we got All Things DG, Dave's Vintage Apple Tech, Alan Gracia, Asmodeus Devil Luke, Trina's Techno Babble, Garth Beagle, Hardware Hacker, Josh, III DIY. Hello, it's been a long time since you've been live. Good to see you, my friend. One Bit Fever Dreams, hello. Adam Baranek, hello. Gut Bomb, hello. Baba Socket Wench, hello. Mr. Tech Gadget, hello. I think that's everyone. If I missed you, say hi again. I'm sorry if I missed you. Major shout out to Mr. Tech Gadget. He's sending me one of his new revisions of the really awesome Apple II A2C DVI. So we'll be showing that off eventually on a stream. So that's very cool. Felt Temp Reparatio, hello. Brad Bell, hello. Good morning, everybody. So yeah, this is the MSX2 that Felt Temp Reparatio gave me for working on the FM Towns UG20 machine. And so this you can see it's a little dirty. That's okay. We've dealt with dirt before. A little bit of corrosion. Oh shoot, one other thing that I wanted to point out. Special thank you to my patrons, because I finally bought an RGB to HDMI. You all are going to force me to be a less janky channel. So again, I appreciate the heck out of all of you. We'll be upping our production value ever so slightly, probably a lot, compared to a lot of things we do here. So very cool. So I'll be learning how to use that thing. So yeah, Jean-Francois Perret, hello. So yeah, let's get back to this. So, what do we see here? When did the MSX2 machines come out? Was it like 1986-ish? They did not have USB ports. Okay, so this is not a good thing. So there's apparently a mod where, you know, because these things require what, 5 volts, 12 volts, and negative 12 volts like every other computer. So somebody devised a system where you could use a USB port to to power this thing, which is not good, because basically this style of USB-A, this is a USB-B, so you'd have a USB-A to USB-B, can only draw about 500 milliamps, and these things probably draw on the order of 2 amps, and so that's not good. So that's really not good. And if anyone knows what these numbers with all these things mean, so that's fun. We have a animal. Oh yeah, that's alive. That's a spider. All right, you go over there, Mr. Spider. You go over there. Okay, you're fine now. There's some. I think the spider was eating in there. So that's that. Sorry if you're scared of spiders. So let's pop this open and see what other things are waiting for us inside here. At a 600 volt delta triphase. Yeah, no, I don't think so. No, I have not yet opened this. Oh, there's a battery door. That. Okay. That it looks like there was some crust at some point on that. Maybe even melted. Does that battery door look melted? That's fun. Anyway. Another thank you to my patrons, Patreons, whatever the heck you all are called. I did a Patreon exclusive post this morning. I bought something very cool this morning that I don't even exactly know how cool it is yet, but it's pretty darn cool. And so I'm not going to show that on stream today. That is a Patreon exclusive for a little while. Super interesting and super cool. So that's another thing we'll be working on at some point this year. So I think we just have 4 screws holding this thing. Hey, it's a Mac 84. We're not even working on a Mac today. I guess we're working on an Apple-ish. An Apple-ish. Oh, Gutbomb knows what it... Well, Gutbomb, you're one of my patrons, so of course you know what it is. Come on, screws. Come on out of there. So One Bit Fever Dreams is working on Spider-Man 1, and we have spiders in this thing. Yeah, this is a microwave, Steve. That's what this computer is. It's just a microwave. Why do these screws just not want to come out? They just keep going. Oh, okay. It looks like this might have been glued together at some point. Okay, there's all of our screws are out now. Oh, I don't have a bag ready. Trina, I'm sorry, I don't have a bag ready for this, for all the bits. Oh my, okay. It's dirty. So we got rust down there. Hello, Hawkward. Yeah. He told me that it was not in good shape, and I was cool with that. Okay. So, here's the first thing that we can see here. Oh, that's Suikapan. Hello. What, has anyone noticed something that's not here that might be kind of useful? There you go, Dave. Dave figured it out. There's no keyboard cable. This is a wireless keyboard, apparently. So this is a very super high tech MSX2. And I forget the full story. I think Feltemp bought this as a restored computer. The cheapest MSX2 on the interweb. So let's see, I'm just undoing all these little clippy clips as carefully as I can, because I imagine this is probably some brittle plastic. Oh, there we go. Okay. So that makes sense. There is no membrane. So this should have a membrane under there. This is no membrane. Okay. So, if anyone has a lead on a Panasonic membrane, yeah, let me know about that. Maybe we can come up with an interesting thing to do with this. I have some ideas. Okay, so the keyboard, or the motherboard, just comes out. That's interesting. Oh, Gutbomb has a great idea. We're going to have a magnet wire membrane. Yeah, let's just use our enameled wire to make a membrane for this thing. So these boards right here, I forget, it's called like the A1C or something like that. They apparently leak and make a giant mess. So that actually looks pretty good. These can be really corroded. Like, remember the TV tuner bit on the Mac TV? It kind of looks like that when it's bad. But that actually, this looks great. That's much nicer than I anticipated seeing it. So what is that keyboard? Or what is the USB? Like, I don't even know if the USB thing's actually attached to anything. So if we go here, AC, DC, and ground. So this system, I think, uses... Oh, I didn't even look at this. What the heck? Oh, bro. Oh, bro. Oh, I was too distracted by the keyboard. What did they do to this thing? Oh, wow. That's fun. This was underwater. This one was actually in a flood. The laser was not in a flood. This thing was underwater. Wow. I hope that's paint. So that's going to need a little bit of an ultrasonic. But, I should be wearing gloves. Sorry, DIY. Okay. This is hilarious, though. I don't think they even attempted to do anything useful. I think they just hot glued that mofo on there. Alright, how are we going to get that off? Yeah. Gloves, respirator, face shield, Tyvek suit, flamethrower. Yes. That is a good tagline. I should be wearing gloves. So, I don't like this. So, this is aluminum. And they have it twist held on there. So that is going to snap right the heck off, I'm sure. Aluminum is very brittle. I'm going to go very slow. Okay. That is screwed on there. I actually just bought gloves. I wanted to actually show them at some point to I DIY. They are a sexy dark blue color. It's too late now. My hands are dirty. So it doesn't make any sense to do it now. "8-bit is the future" was the seller of this thing? Wow. That's embarrassing. They should be embarrassed anyway. Alright, so there's a little dab of hot glue in there. I see no solder at all. Hey, Retro Fox. Yeah, this is the MSX that I got. I think they just glued this. Oh, that's not hot glue. That is super glue. That is super glue. Okay. Oh, you bastards. Excuse me. This is funny. This is restored according to them. So yeah, this is gonna spend some time in the ultrasonic bath next week. But we're gonna hit this with some hot air. We might need. Oh yeah, that's definitely super glue. I can smell that. We're getting bigger pliers for this one. There you go. Oh, man. Okay. So here you go. You can see that those are the pins for the USB that were not going anywhere. What freaking scammers. Wow. Here, Retro Fox, if you didn't see this, here's the bottom. This is a very cool setup though. Like, look, all the electrics, all the chips are up here, but all the wiring's on the bottom. So yeah, this is bad. Yeah, this is not incompetence. This is straight up scam. Excuse me. So luckily, there's not a whole lot that is proprietary. There are, I mean, you can see logic chip, got a Z80 CPU. This thing is most likely proprietary, and unfortunately I do see something that looks a little burned down there. But we'll get this cleaned up. Yeah. Even if you don't like this, make sure to hit that like button, folks. This might be factory bodgy. I don't know. So anyway, did I say hi to you yet, Rodville? Hello. Yeah, it's a single layer PCB. And I mean, look at the traces. Look at how cool that is. Everything's curved so the electrons don't get stuck. They flow real nice. This board has lots of happy electrons. Well, not right now, it doesn't. But Someday, hopefully it will be. Okay, so that was fun. I'm gonna go take a bath. Okay, all right, so one janky project. Let me go grab a, here, you guys can look at that. Here, take a look at that a little bit more. I gotta go grab a bag to put all those bits in. Alrighty. Don't want to lose all my stuff. Trina will get really mad at me if I lose any of the parts. And let's be organized. Let's even label this. Scammer. MSX2. Alright. Yeah, I don't know if it would be fun to know its full history, but it's mine now. So we're gonna get this thing working. Hell or high water. Oh, actually, high water. Yeah, this thing was in high water. That's for sure. Let's have a quick little bath real quick before. Yeah, don't do this either. Let's do that. You're in hell. I touched that thing. Okay, well that was certainly entertaining for me. So I hope you all got a chuckle out of that. Oh, there's gross bits everywhere. Don't wash your hands like this. This is not the right way to wash your hands. Okay, so out of the frying pan and into the fryer, or whatever the heck that expression is. Let's get back to the Laser 128 that I can't even say his name. I'm so mad of it. No, Javier sent me. Let's do a close-up on this PCB real quick so I can show you what this is. And again, let's go back to here. This is what that PCB is supposed to look like. I'm going to orient this thing so it's the same way. Let's go on the microscope and take a look at this. So there's the top corner, and this is some of the corrosion, and then here's some more of the corrosion, and some more of the corrosion. Here's the fun bit. There's no corrosion right here because there's no copper left. So this thing used to be like a ground plane, and it would wrap around and it would go to there's pins here, right? Here's all these pins. And this ground plane wrapped around that, right? Let's go back to that other bit again. Zoom in. No, that's not going to work. Sorry. You're going to have to go to that website yourself. The link for this is in the video description. But yeah, there's that ground plane goes around there. Also, while we're looking at that, check out this guy. There's a inductor there, and there's an inductor there, and then there's a capacitor up at the top. And let's go back under the microscope. And here's, they did replace capacitors with something else, but this capacitor is now sort of two capacitors, so that's fun. Here's where one of those inductors should be. It's not there. That trace, it still might be connected. We can't even tell where that other inductor was supposed to go. And there should be another capacitor up here somewhere. Look at this capacitor. That one just just went away. There's lots of angry traces. If we go to the back, you can see there's even spots where I still haven't gotten through the solder mask, but there's bad traces. And so Javier mentioned that this was in Katrina. Katrina, and I forget the name of the person that left a comment in my last stream. This was apparently not in the flood from Katrina, but it was in a storage unit since Katrina, I think was what he said. And this is the battery. This is all due to the battery. Hello, Marcus. It said unused Apple II GS inbox. Yeah, no, it's not an Apple II GS inbox. So the battery is what destroyed this thing. And you can actually see there's little holes here where this ground plane's been eaten through, and these are the vias that connect the ground plane to the other side. So this is all going to have to be redone and covered up. So this thing mounts to the PCB here-ish. And so if we look under there, this was the header that existed there, and I ultrasonic this the other day. But you can see that some of the copper came away with it. So there's definitely screwed up traces under here. So this is not flood. The Louisiana humidity helped. The battery is really what did this guy in. So if we look here, you can see this trace should be going there, and it's not. I don't know if it's actually supposed to connect to any of those things, but that's gone. This trace should be going through there. It's gone. This one comes here. I have a feeling it goes to that one, but I don't really know. So this one's a problem. I don't know where that trace should be going. So that's an issue. You can see that this is like a little ground plane. This is still connected. It's not happy. This has a giant hole corroded right through it. So that's not good. And then, so I did a bunch of reading. Also in the video description, I started making my own document with some of the important bits from the schematic. And so I have some of this stuff there. But this chip is, so they call these the gate arrays. Basically, they're combined logic chips to do fancier stuff in smaller footprints. And so this gate array 1 is the one that should be taking in the system 14 megahertz. So last time we found out that our 14 megahertz crystal was working and that it was going to this 7404, and that was good, but we couldn't figure out where it was going. Part of the reason I've ultimately figured that out is because they mislabeled some of the resistors and whatnot, and so it really goes through this resistor and then it comes out over here onto this chip. Then this chip takes that 14 megahertz clock and divides it into other clocks and sends it around the board. So one of the things we saw before is that the other clocks just weren't being generated. But the other thing we didn't check before is the reset. So that's one of the things we're going to do today. But the first thing we got to do is let's repair up these traces that are gone, just in case they're doing anything important. This right here, this trace goes 2 places, so that must be important. Let's go here to beat mode. So here's a via. You can see it's not connected to that side, and it's not connected to that side, so that needs to be fixed. So let's do that one first. What other things did I find out? Oh yeah, there's supposed to be a chip here. We got to put in a holder. This holder, this is after the ultrasonic bath. You can see there's crud down in the socket, and there's a lot of the pins are all deformed, so we're going to replace that socket. It looks like all the traces under that socket are okay. It's just the ones over here where the bad stuff. I have a picture. I forgot to grab it, but there was green kind of oozing out underneath of that header when I took a look at it the other day. So that was unpleasant. All right, so what do we need? We need some wire. We always need some enameled wire around here. So if you want to follow along with the schematic or help me figure stuff out, like it's such a shame that book, there's a lot of good information in that book, but it has issues, and it's missing some details, and it's hard to see certain things. Oh, I guess Gut Bomb's running a little late. Yeah, I'm not charging Javier enough, I'll tell you that. So actually what I'm going to do is I'm going to cram something in that via. How come I never say via the same way? I mostly say via. Sometimes I say via. Okay, he's caught up now. So yeah, so let's cram this in here. Put you in there. At least the traces are nice and big on this one. And we'll put a little solder on that one. That is a good theory, that maybe someone didn't intentionally scam like that, but maybe they accidentally sent out a parts machine instead of a restored one. I'd like to have some faith in humanity, but I don't know. It's becoming harder and harder every day. Okay. Where I had a little piece of wire here ready. Oh, yeah, I did. Okay, here we go. So let's get fancy. Where are we? Can you even see anything? So we're gonna take this. Need some tweezers, some more different tweezers. Feltemp did tell me that it was bad on the inside, so I knew what I was getting into. Unfortunately, he didn't when he got it, so that sucks. Now to make this one super duper strong, we're going to go nuts with this. Since we have some space, we're going to wrap that. That's not a thing I do very often or ever, but I want to know what's going on with that. So we're going to wrap that around there. This is a very special bodge. We're getting crazy with this bodge. Hey, it's Eric's Edge. You missed some fun. Fun with quotation marks. Now we're getting back into the laser, which is also fun with quotation marks. Come on, you jerk. It is very cold in my workshop today, so apologies for the extra heater noise. I really needed it today. It's definitely cranking. I also have the oscilloscope on. Okay, that bodge is there. Did we fix that bodge? So from this one, that's good. We go all the way to there. That's good. All right. I think what I'm gonna do, I would not do this permanently, but I think I'm gonna, is this actually good? Nope. Okay, that one's good. That is not good. That's okay to there, but that's dead there. Oh, let's do real bodges underneath the socket. I was thinking of just running some wires, but let's do it the right way. I don't know where this one goes. If anyone has any concept of, so this is the little header for the real-time clock. If anyone has any idea how to figure out where this via connects in here, I have a feeling it's that one, but I'm not going to connect that today. One of the things in that thread they mentioned is that the EX2 requires the real-time clock in order to boot, which is really interesting because the EX2 board and the EX2 the EX and the EX2 board are exactly the same. It's just the real-time clock being on one and not the other. So maybe the BIOS is different, but apparently we should be getting some like white vertical bars if this powers up correctly without the real-time clock. So at least that would be different than what we're currently getting, which is absolutely nothing. But considering we have no clocks, that makes absolutely perfect sense. Your computer does not do a whole heck of a lot without clocks. Hey, it's Joe's Computer Museum. Joe, do you have a Laser 128 EX2? Or actually, I could even deal with an EX. Because one of these traces is so corroded that I can't even tell where it's supposed to go. So we're just doing a little trace repair here so far today. You missed a really disgusting MSX2 that somebody got scammed, not me. So this guy is going to run down here. It's not going to be my prettiest bodge, but we have space to work with on this board, so it'll be okay. It'll be okay. I went back and looked at that 286 board from a couple weeks ago, and I needed to do 4 more bodges on it. And I compared the bodges I did now compared to the bodges I did way back then. There were 2 that I had already done on that board. My work has improved a little bit in the year or so since I did that 286 board. It was a little rough, those older bodges. And of course they always go better when I'm off stream, because I can use both my eyeballs. Okay. Gonna stick that down in that via. Did anyone decide on the right way to say it? I guess even if you tell me the right way to say it, I'm still gonna say it wrong. Sometimes, half the time. Come on, Bodge. Go to your little home. It is kind of unreal how much easier it is when you have both your eyes available to you to see in 3 dimensions. It's Ian Scott. You missed all the nasty bits, Ian. You might want to go back and watch if you're into horror at all. Gore. Electronic score. Okay. Alright, there's that bodge. We should have 2 more in this area that we need to do still. Hey, it's Eric Helgeson. Look at that. Garth with the promo. Everyone is going to be beating down the doors to get their Pico IDE. Very exciting. I'm excited to get one. Oh my gosh. And how about this week with Blue Scuzzy? It was an insane week for Blue Scuzzy. At first, we were like, holy crap, they're adding a way to add digital audio. And then the next day it was like, holy crap, we now have ultra wide and wide and I don't know, faster Blue Scuzzy V2s and SCA. Like totally crazy news coming out in Blue Scuzzy world this week. Very exciting. I, for one, was shocked at this announcement. I had no clue that this was about to happen. Okay. Is Joe a mod? Joe, you can feel free to add your link to pre-ordering the fancy, newest, fastest Blue Scuzzies. Maybe Garth will get it. Garth is handling all the link-a-madoodles. Mr. Tech Gadget missed the announcement. Were you under a rock? It's the biggest news since the Beatles. Uh-oh. What happened to your TV, Trina? That was a good retro thing. Oof. What did I do here? What is going on? Who is doing this bodge? I'm embarrassed for all of us. What is in there? There's probably some schmutz in that hole. Nope. I was just being incompetent. Thank you, Gut Bomb. I swear I'm better at this when I'm not on stream. Doesn't do the settings I want for testing stuff and the HDMI. Huh, that's interesting. Can we just blob bodge this one? No, we're gonna have to suffer. Alright, sorry folks. One more. Get in there. Okay. Bit flux. Okay. All right, I think that's it. Let's test these bodges. Make sure that they're all bodged up. So that one's got to go from there to there. Yay. From there to there. Yay. I don't know where you go, so you're just leaving disconnected for now. And then this guy comes around there. Goes all the way up to there. Yeah, okay. That's good. All right, let's see what happens. Oh, we gotta put a socket in. Okay. This needs to be socketed. So what are you? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We need a dip 20. Do I have any dip 20s? Yeah, I do. Okay. This is all going great. This chip does look a little scarfy. You can see all the bare copper, but I did check it, and it is functional. So that's good. I think this goes this way. All right, let's go out of the microscope, and we should be able to do this one just out on the bench. Oh gosh, my stack of 68040s just fell. Oh yeah, that's a whole nother thing. Oh, there's other bodges. Oh, there's other bodges that I had to unbodge. It's okay, Garth. They were broken 040s. So this, just showing you some more of the mess that I still need to work on. Where is it? Oh yeah, just those blue things. That one. Oh, we could do it under the microscope. I can show you. I don't know why they decided to use the well, I think they call it the triangle button in the manual. Okay, so this bodge went to there and this bodge went to here. I do remember that. I don't think we need those because I think that's purely for the real-time clock bits today. So I think we can skip that. I do have extra wire coming out here. I want to make sure we don't short it on anything. Just going to take that off real quick. Okay. Oh, I guess we could do this while we're under here. Solder up these. There we go. Ah, okay. Yeah, I don't know. This is definitely an era of computers that I know an exceedingly small amount. Especially from a technical standpoint. I mean, I used an Apple II when I was a kid in computer class, but I sort of skipped over the 2C line. Didn't know anything about the clones. Alright, who's ready? Who's excited to shoot some electrons at this thing again? I know I am. As Ron says, if you're like me, and I know I am, let's put all the solder on there. That's a lot of solder. Where are we going? We're going back out to here. Okay. Alright. I think what I'm going to do is just put a little piece of tape over those bodges so that they don't attach to other things. Chart says Blue SCSI Ultra will support Dynaport, but I don't see an antenna on the board anywhere. Maybe it's integrated into the PCB? I don't know. I mean, oh, yeah, no, you can kind of see where the antenna is on the Picos. Let's just put you there. And then put you over here. Then we'll figure you out later when we get back to that mess with this thing. This is going to take some work. Okay, so then this chip's got to go back in. Hopefully this is all happy now. Let's straighten out the legs a little bit. Okay, I think that's off. Let's grab our A2C DVI. And, well, got our oscilloscope ready. HDMI is good to go. Oh, let's get silly and put a speaker on this, even though I don't think that's going to happen. All right, 3, 2, 1. All right, so we're still getting nothing. So the A2C DVI sees that something happened, but it's like, no, we're not getting any signal here. All right, so let's go back and see what we have for clocks. Let's see if we have any other clocks. So, excuse me. So again, what's supposed to happen is that this 14 megahertz clock gets passed through this 7404, and then that goes out across the board, goes to this chip. This is the A1 gate array. Then this one generates all the other clocks that the board needs. We should also be able to detect the 14 megahertz clock in other places. So what I'm going to do, I printed out the schematics to try to make them look a little bit easier, because it was hard sort of balancing last week, showing you guys stuff and me trying to see stuff. I also made a document in the video description if you want to follow along with some of these things that I tried to do to make it easier to sort of isolate bits. So, okay. So this is the A1 chip. We should have the 14 megahertz clock coming into the top of this thing. So let's get into the microscope. Let's add, excuse me. Let's hide that for a second. Let me show you this. Okay. So, just to prove that we do have a 14 megahertz clock somewhere, I think if we go to this pin, yeah, there we go. So there you can see, you probably can't see with the software, but this is 14 megahertz. Okay. And then if we go to this other place on the board, we still have 14 megahertz. And if we go to R135, we still have 14 megahertz. According to the schematic, that I think was R136. But let's go in the microscope and just check real quick some of these other pins and see if we can see clocks in other places. So let's hide. There we go. All right. So this is our A1 chip. And if we go, we should need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13? Nope, 13's our reset. 14, 15, 16, 16 and 17 might be it. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16? Nope. 17? Oh, there we go. All right, so our 14 megahertz clock is coming into this chip, so that's good. Now we should have other clocks leaving this chip. So this pin should be a data pin. We got no activity on the data lines. Shoot, I should have marked that. Where was that one? All right, there's our 14. 2 down. So this is supposed to be our 7 megahertz clock. There's 14. That should be ground. And then we should have a 7 megahertz clock, which we do not have. Okay. So then we should have a 3.8 megahertz clock, which we do not. And then we should have something else, maybe an IRQ. And then we should have reset. So what happens to this? This should be, so that's off. We go right to that. That's saying we got a good reset. All right, well, let's see. I think that's reset. It's so hard to see on these stupid schematics. All right, I'm gonna go back to my other document real quick. So this chip is not waking up, right? If this chip were waked up, it should be generating the other clocks. So I feel like we're not getting the proper reset. So this is my document. Oh, let me show you this. Bloop. Let's go back to here. So there's a link to this document in the video description. So I've pulled out certain things that I think are useful. So again, this is how the clock is generated, blah, blah, blah. And this is, oh, down here. This is showing you more specifics. So I think like this number is wrong. That should be R135. That's saying R136. I haven't been able to find some of these. I found U26. U26 is fine. That one's happy. And that's working properly. I don't know where L130 is. I haven't been able to find that yet. So that's always fun when you can't find the bits on the board where you're supposed to be able to find them. But let's go to this reset line. So U18, I think I found U18 over here. So U18. Is, yeah, this 7405. And pin 8 should be one of the drivers of our reset. So 1, 2, 3, 4, 5, 6, 7, 8. What happens here when we power this off? Can we see? Oops. Nope, you can't see anything because my hand's in the way. There we go. There's pin 8. So what happens here when we have powered off now? 3, 2, 1. It kind of does a little blip and then doesn't do much of anything. So that might tell me. So it's pin 9 on there. Pin 9 is high. So that's interesting. So reset on this thing is low. So 9 eventually goes up. But 8 stays low. So that's telling me that this thing's not coming out of reset. So should we see if the 7405 is broken? Yeah, John. Let's see if the 7405 is broken. Okay. Thanks, Dave. Dave's always a great moral support. And Gapama's joined in. All right. Let's see here. We could also we could do it the wrong way. We could like force it to go high. But generally, if it's not going on its own, there can be a reason. Now Gutbum would prefer that we do it the wrong way. No, let's do it the right way. Let's pull out the 7405 and let's see what it looks like in the retro chip tester dealy majig. The problem with doing it the wrong, I guess I could just solder a bridge over it. No, that's the. If the 7405 is okay, then do it the wrong way. Well, no. If the 7405 is okay, that means that there's something else telling our reset to not reset. But I don't see any other uses of U18 anywhere. Maybe we can. I don't know. I'm just a guy doing a stream. Sorry, just waiting for the hot air or the desoldering gun to heat up. So again, this is where we were at on the board. So our voltage bits are over here, and I guess the voltage bits kind of signal over to this and say, hey, yeah, we're ready to go. It's time to do a reset. And then it sends it over to this, from what I can tell, this little transistor bit. Maybe we'll take that out too and see if that's still a transistor. As far as I can tell, let's look back at that real quick. Q12. $7405 not going high is open collector. So could that mean that our Q12 is bad? Is that what you're saying there? Oh, shoot. Don't drop your this onto your desoldering gun. Let's pull out Q12 real quick and see what that looks like. What's going on there? Where are you? Let's see what Q12 does. Let's see if that still looks like a little jobby, or if it looks like a resistor. No, that's showing as a thing. Okay. So that's useful to know. We do have a really angry looking capacitor right there. Is that capacitor shorted? Nah, that's fine. Let's pull the 7405 off. We got nothing better to do, right? I feel like Gut Bomb is chaotic evil. There. Put you up. Man, this thing doesn't want to come off. There it goes. Now you're free. Almost. There we go. Oop. Don't see anything wonky around the board there. Get it right, Gutbomb. That was not hot glue. That was super glue. Woo. Okay. Bloop. Let's turn this guy on. We gotta justify using the fancy equipment. Oh, yeah, yep. I do not have a chip leg straightener. I do it old school with pliers like an animal. Saying our 7405 is okay. Now, why would the 7405 not want to wake up? I guess we should do this the wrong way. Right, Gutbomb? He's excited to do it the wrong way. Here. Okay. Sorry. This one. Oh, there was a nice big ground plane hiding back there. On both those. Okay. So while we're under there, let's see. Let's take a look at that and see where things go. These are the two pins that are supposed to be going places. This is our input. And then this is supposed to be our output. So the last one. And then it goes down to the other side of the board where that other stuff is. So that's all fine. So there's that, I guess, a hex inverter. Yeah. Other pins are used for stuff. I wonder if any of the other pins do stuff when you power it up. So it's 14. What the heck, bro? Look at this. I I got scammed out of a leg. Said I want my 3 cents back for that. Okay, let's go back to here real quick. Yeah, I don't know. I don't think I could design a new one of these, Trina. Although it would be easier to just boot up an emulator than to fix this. But you know me. I like to spend an inordinate amount of time repairing things. Yeah, with tariffs it's $10.03. Oh, no, not that. There we go. All right, here we go. Let's solder this thing back on. It's Francois Reval. All right, Francois, tell me why a 7405 would not do the thing. The 7405 is responsible for the reset circuit waking up, and it's not activating. Brad Bell says it's because of an open collector. I don't know what that means. I'm not smart like y'all. I just know how to poke at things. And of course, Gut Bomb just wants me to short it, to wake it up. Oh, we gotta put this guy back on. This guy tested fine. He wasn't shorted. Adrian always does things the right way. Don't confuse me with Adrian. Alright, let's go back. Let's go back to here. Gotta clear out that via. Bloop. Adrian would do all the work to figure out why the 7405 was not 7405ing. We know the chip is good. Just don't know why it's not sending the signal out. Actually, I didn't show y'all. This might get me canceled. Or maybe I did show you. This is an LC475. Look at that. Look at that naughty bits. Look at that naughty bits. Naughty bits. Uh-oh. Yeah, that goes that way. Sorry, I forgot for a second which direction that goes, but I'm pretty sure this goes this direction. Put you away, LC475. That was totally recapped with ceramics. Okay. So that's all back together. So we can shut this off now. All right, so just to summarize where we're at here. We know our 14 megahertz main clock is good. It goes into this chip. This chip is not sending out all the other clocks that it's supposed to do. And I think that's because we do not have a good reset signal coming into this chip to wake it up. If we look at this 7405, if we look at this, this dealie, pins 8 and 9 are part of this. So 9 is bringing it in. 8 should be spitting it out. 8 should be pulled up to 5 volts with R69. Oh, right. I couldn't find R69. Yeah, I feel like R69 doesn't exist on this board. I see R67. All right, so let me show you this. Let's. This might be another just wrong thing. Okay, so where pin 8 comes out should attach to both R69 and R70. So let's go back. Let me show you something under the microscope. Where's OBS? I lost OBS. Okay, here we go. Okay, so let's see. So I see R70 and I see another one right next to it that looks like it's attached. So I bet you R67 is actually R69, or maybe it's R68 in this diagram. So if we probe one side of those, they should both go to pin 8 of the thing. So let's see if that is how that works. Okay. Let's try to think for a second instead of just poking at stuff. I'm sorry, Gupom. I know you like to just poke at stuff. I like to poke at stuff too. But let's see here. So go to beat mode. Let's go to, I'm gonna put my one probe on pin 8. Okay. And let's see. Yup. Okay. And so these two should be totally touching yes. Okay. Okay. So that's something. Okay, so these two are the same thing. They're not the same thing. And these both go back to pin 8. Or they did. Oh, that's the wrong thing. Okay, so one of these is a pull-up resistor. Then the other one goes to this guy. Okay. Alright. Alright. Alrighty. Okay. So if we go back to this, right? This was our two spots that were together. One of them should go up to 5 volts. The other one goes to this transistor dealy. So should we, yeah, let's see what these resistors read. Let's see if they read the right resistances. Let's go back to the microscope. $3.3K. 3.3K. So the resistors are both good. All right, let's see. I'm gonna plug you in. Let's go back to here. Okay, that should be off. Let's plug this in. Just for poops and poops. And let's go to voltage. So, these were both the same spot. One of these should be 5 volts. I guess that should be probably R67, which, let's go back to that picture again. Well, we know this one goes over to here, so this one should be the 5 volt one. Okay, all right. Go back to here. Let's switch on our machine. All right. So this one is going up to 5 volts. But even though our input is 5 volts, it's not turning on. No, there's not a better scan of the schematics, at least not that I've found. And just to refresh ourselves, we should have, yeah, good -12, good 5, good +12. So all of our voltages are good. There's just something not happening right here. This thing's not waking up. Our signal's not turning on here. Add more amps. Hey, CDI. Oh, why are you not waking up? So do we have the same kind of thing happening on these other ones? So let's see. Yeah, these should be... Yeah, we're not getting our pairs waking. Oh, does that one wake up? Nope, that one didn't wake up. So this is just, what wakes up a 7405? Why are you not waking up? Let's see. Let's look up a 7405 pinout. Uh-oh. Oh my god, my mouse. I need a new mouse. Can you believe it? No, I cannot. Alright, so pin 14 should be VCC. Do we have voltage coming into the chip? So pin 14 is this guy. We got voltage coming into the chip. Oh, you're correct. It's an inverter. So it should be low. Thank you, Josh. Yeah, so no, that is functioning correctly. But for this computer, our reset signal is low. Oh, there is a nicer scan? Oh, that would be useful. So the output, there's our capacitor. Okay. So this is our output of the transistor. That should be our reset signal that goes to other places. So let's shut this off for a second. If we go back into beat mode, so that should be our reset as far as I understand. And then that should also connect somewhere up over here. Yep. All right. So our line is connected. For this one, if reset for for this computer, if reset is high, no. Oh, I've confused myself. I've confused myself again. Let's see here. Let's watch what happens on this. All right. So let's go to voltage. Turn on. And our reset goes high. Oh, is that? I have totally confused myself. I thought we were like making progress. And Josh is making it worse. Thanks, Josh. Okay. All right. Well, I think we figured some stuff out, and I think I've confused myself even further. What happens? All right, let's try a thing real quick. I'm sort of running out of juice for today. This stream was too exciting. Whew, buddy. How do we do a reset on this guy? On this? Don't you have to do like a control reset? Let's add our keyboard. Oh, we're on. so let's go back to here. Oh, where did my other lead go? Put you in that hole. Put you in this. Okay, there's that. Oh. Oh, it works. Look at that. Okay, our reset line is working. Okay. Okay. That's a thing. So I was wrong. So if the reset line is high, that means we're not in reset on this computer. Okay. All right. I think that's correct. That's something. Right? Does everyone agree that that is maybe something? Let's try. Okay, look. Here, we're doing it on this one. There, it popped up for a second. It does come out very slowly, though. Shouldn't the reset be a lot tighter than that? Okay. Okay. I think that means something. I think our reset needs to be much tighter than that in order to work properly. Okay. Collectors. Leaky C41. Why the heck would C41 be? Oh, is that our... C41 should be over near U18. What's D17? There's a diode over here. Oh, there's C40. Okay, I see C40. Oh no, C41 is what we want. On the schematic, yeah, that's great. That's great. Let's go here. Do we have... What's happening with this diode? So there's this diode should have 5 volts on one side of it. That's interesting. So this should be, well, oh no. Alright, so this is D17. Let's see if that's really the one that's going into pin 9. D17. Yep, that's the bright one. That's going over to 5 volts. So that diode's good. Now we just need to find C41. Oh, it's this guy right here. This is C41. Alright, should we pop out C41? Let's see if he looks bad. Okay, so this was D17. Again, show that that's there. That's all happy. This is our C41. And I guess we could also look at C50. Even though it looks like, oh no, C264 is also one. And C264 looks a little sketchy on the board. Oh shoot, no. I just hit close OBS. Okay. If we go back to here, so C264 on the board looks real bad. Let's check out C41. Let's see if that has anything to do with anything. But we gotta get going. This will be the last thing. Let's do this as the last thing. Let's see C41. Oh, sorry. Let's go back to here. Okay, C41 is that guy. Yeah. One doesn't want to come out. Give it some fresh solder. What kind of cap are you? 4.7 microfarad, 10 volts. Let's see what you have to say, Mr. Cap. Or whatever kind of cap you are. That's pretty good. That's not the worst cap I've ever looked at. 1.2 ohms, 3.1% V loss. Let's see if mine are any better. 1.2, 3.1. 47. Uh-oh. Oops. I only have 16 volts that are gonna... It's gonna make it look a little better. Let's see. Yeah, see, that wasn't the worst cap ever. Whatever. Let's try it, just for poops and giggles. So on all these, oh, well that's not annoying at all. So the white hash is the positive side on this. If you're following and recapping at home. Oh. Okay. It's not the prettiest job in the world. Yeah, don't you love the cables, the way they did these, soldered them right onto the board without the connector. Makes it nice and durable. Alright, let's see if you did anything. And of course, because we're silly, we're gonna do this. We're gonna pretend like this is just gonna work. Putting one cap in the startup circuit. That is totally gonna fix everything. Let's see, do we have anything shorting out anywhere? Nope. Okay, let's do this. Go to ground. Let's look at voltage. Yeah, that's just so slow. Maybe the power supply needs to be recapped. Let's see here. Let's shut that off. Let's look at our 5 volt. If that's coming up slow, then it could be the reason we're not waking up right. Alright, so I have us on our 5 volt right out of the power supply bit. No, that's 5 volts immediately. Let's go to 12. That's 12 volts immediately. This. Look at that. Look at how slow that is coming up. There's something wrong there. So that's our pin 9. That should be coming. That's what's coming in to U18. Why is that coming? So that diode is good. So sorry, let's go back to this guy. That R39. That, yeah, like, so if we look at this, R39 is our last thing here that we haven't checked. We replaced C41. This diode looks good. R39 is the only other thing it could be. So let's look at R39. Where the hell is R39? And is it actually labeled R39 on this board? Oh, here we are. R39 is underneath this piece of glue. Okay. Alright, let's... Oh, okay, that's off. Alright. Let's check our resistance. So R39 is under this mess. Yeah, I need something to poke at R39. Uh-oh, I said a bad word. Sorry. Sorry if I said a bad word. Sorry, YouTube. Sorry, everyone. I've let you all down. I saw a YouTube ad with cussing in it. I might have said this the other day. They were using a song in one of their ads. And man, there was some cussing. So much cussing. Oh man, if you've hung out this long, if you wouldn't mind hitting the like button if you haven't done so, that would be swell. I appreciate the heck out of all of you. I think this R39 exploration is going to be our last bit for today. This hot glue is very goopy. It's not really hot glue, is it? Alright, let's just poke probes down in there. Yes, there's so many more wall repairs that need to happen. Oh. No, why am I doing that? So, what do we got here? 9.2 kilo ohms, and we got orange, orange, orange. As far as I can see. So what's orange, orange, orange? Somewhere around here I had a thing open. Nope, I lost it. There we go. Orange. Orange. What's our last one? Is gold. 33 kilo ohms. We're also sort of going through. But that doesn't make sense. That makes no sense. So that's saying that R39 has extra resistance. So orange, 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 if I'm reading that right, is 33 kilo ohms. And that's a lot less than 33 kilo ohms. But why would you have a 33 kilo ohm resistor be your... That doesn't seem right for that particular location to me. If we look back here, right, this being 33 kilo ohms, being our pull-up to 5 volts, that feels weird to me. I mean, it's right next to diode 17, so it makes sense that that would actually be R39. I guess we could desolder it and see what it looks like. If it really... Oh, I don't even... Alright, no, we're gonna have to end because that... Let me show you this resistor in the microscope. This is gonna take some effort to get out. Are we off? I think we're off. Let's unplug just in case. So diode 17 looks good. R39 is embedded in this, and it looks like hot glue, but it is not hot glue. It is like goopy, very hard stuff. So I'm gonna have to desolder it and then sort of dig it out of there, and it's gonna fight me, I'm sure. Okay, well, it's almost like epoxy. It's more pliable than epoxy, but yeah, it's kind of like that. All right, so let's get out of here for this week. Oh, this was a lot. Thank you all for hanging out for 2 hours poking at this thing. We got to see a weird MSX, so that was fun. We're gonna do that eventually. Let's say thank you to all my patrons. We got my Janka crew, Matt Hargett, Gutbomb, Garth Beagle, Brian Gareford, David Starbuck, Ian Scott, Jamie's Hack Shack, All Things DG, Chris Angelis, Tech Ambrosia, Scout, Jack68K, Bacchus, Asmodeus Deviluke, Alan Gracia, Rudy's Retro Intel, Dustin Cooper, and Suika Pan. My Jank team, Hardware Hacker, Mark Kruger, III DIY, Charles Bullock, Dave's Vintage Apple Tech, Mark from Millennium Max, Mr. Tech Gadget, and Mike K. Thank you all so much. And again, you're making my channel better because I bought that HDMI or RGB to HDMI that I'll be incorporating into doing stuff, which is totally a huge upgrade for the channel. So yeah, I really appreciate the heck out of all of you. And I want you all to have a really lovely week. I've got to go back to work after having a whole bunch of time off, so I don't think I'm going to be doing many more midweek streams. Maybe if I get frustrated, I'll blow off work a little bit early and do a midweek stream again. But mostly we're going to be doing Saturday at noons from here on out for a while. So yeah, have a lovely week, y'all. And as we say here at the Big Bad Bench, if you're a Trumper, what the hell is wrong with you? Go F yourself. Bye, y'all.